Hello there, I'm Kadir. I hope you are doing well. So today I will be explaining a multimodal rag app that I have recently did. The idea came when I was doing my research on my thesis for my master's degree. And as we all know, documents and PDFs contain a mixture of content types, including text, tables, and images. And I thought, why won't I make a rag to answer specific questions on the papers I am doing my research on? However, I thought that if I go with the classical approach in RAG, which uses only the data found in text, and eventually the information captured in the image will be lost. So that is why I went with the multimodal RAG approach that utilizes the data captured in image 2, using them to ingest for ingesting the image in the uh, context parts to power up my prompts that will be used in multimodal LLMs such as GPT-4 o. So I will go in a step-by-step explanation on the graph. So this part in here is the part where we parse the image, tables, and text from the document. And this is done using unstructured library which utilizes Poplar for rendering the data from the PDF and processing them, and Tesseract for the image part. This part is used for all three options. And after that, I will be going with the first option. This option has a chain that uses LLMs for generating summaries on the raw tables and texts. It's only text, no image summaries is being generated in here. After that, we will go to the multi-vector retriever part, which vectorizes the summaries that I have generated in here and referencing them to the raw data so that when the retrieval, the similarity search is going on, the raw data will come to the context in my prompt. But the thing is, in here, I for the image part, Clip is being used. Clip is a multimodal model that can be used for similarity search between texts and images. But the thing is, Clip isn't strong enough for the moment. At the moment, I did try using Clip for the retrieval part, but unfortunately, it didn't give me good results. The image wasn't retrieved depending on some user queries, so I didn't go with this option. But essentially, in this part, the image vectors is being generated using Clip, and the others are generated using OpenAI embedders. And let's go to the next option, which is the part where we add the image summarization to the chain, where we do the summarization part. So in here, essentially, we get the raw data of the tables, text, and the image, and use an multimodal LLM to generate summaries on the image too, so that we can take the summaries and vectorize them and reference them to the raw data so that when we retrieve them, we can use them in the prompt. And in the second object, we are using the summaries, not the image itself, the generated summary to be added in the context part that will be ingested within the prompt for answering the user questions. But I believe that the best option is the third option, which is the one which is kind of similar to the first option. We do ingest the image in the prompt, but the thing is we can't actually retrieve the image, not such as Clip, because in this part, when we do the retrieval part, the similarity search is being done between the query and the summary of the image, not the image itself. So I went with this. I did actually test all of the options, and I found that this option, the third option, was giving me the best results. For that, let me wrap things up. We I went with the third option. The data is being rendered and parsed from the documents. I generate summaries on them using a chain, a hard-coded chain. Then I add them to the multi-vector retriever and reference the vectorized summaries with the raw data. Then this data is being calculated, the similarity of this data and the query is being calculated for every query with the query for me to ingest the context that came from the retrieved data within my prompt. And let's go to my demo. So this is the part where I use the preprocessor endpoint. At the moment, the data within the PDF is being parsed, the summarization process is being done in the chain, and the multi-vector retriever is being initialized. And it might take some time. So let's try some questions that I have tried before to showcase the power of adding images in our prompts. I will go with this question that is asking about a specific thing, which is the outreach bonds in 2015, which isn't found. This data, this is the retrieved data, the texts and the image that has been retrieved, and I couldn't find any data about that in the text. But as you can see in the image, the data is found, which is 10.13 million aggressive bonds has happened in 2015 for our question. Let's do another question, which is asking us the range of changes in wildfires between 1993 to 2022. In here too, the retrieved data is a table, the text, and a graph, a nice graph. As you can see from the answer, it is telling me that it told me which figure is used in there, and the number of the wildfires has decreased slightly over the 30 years, and annually has generally increased, which has been taken from here, of course. It has decreased, as you can see, the red line, and the increased aggressive bond ratio is shown in here. And that is all, actually. That is what I was trying to explain. Some answers can't be generated using text only. So why won't we use image too in our approaches? And I hope that this idea can be used in a bigger project, such as using it within an agent, so that this chain, this RAG chain can be used as a tool within the agent, and we can do much more with this approach. Thanks for watching me.